you're about to see is being rendered dynamically from data being ingested from the NASA Exoplanet Archive. So here we have the star field, and these are only the stars that have known exoplanets orbiting them. So here's our Earth, and you'll notice that the stars are very large. That's because we haven't worked the scale out yet. It's a little easier working with the stars when they're this big, and what we have here are, for every meter is a light year. The textures that you see right now are temporary. They're just randomly being generated and applied. The ultimate goal is to create a dynamic shader based on the data, and to be able to interpret that data and make decisions about how it might look based on the data. That's our ultimate goal. There's a lot of complications to doing that, and we're going to need some help from the scientists, and some creative license will be taken either way. Star TOI 125 has 2 planets orbiting it. The relative scale of the planets in the star is accurate. The absolute scale is not accurate, and certainly the scale of the size to the distance from the star is also not accurate, and we're working out ways to display that data in such a way that you're actually able to see the planets and understand that a scale has been applied. Otherwise, these would be so tiny you wouldn't see them. The distances between objects in space and the size of the objects are massively different. So we can point to one of the planets and get data on the planets. Right now, this is just test data. It was discovered in 2019 with the method of primary transit. Again, this is just proof of concept. The actual application will be much more interesting than this, and it will be teaching the viewer, what is a primary transit, what kind of star is this. Different stars have different characteristics that make life more or less likely, and so we'll be learning about all of those things.